Here are the instructions for our Expanding Universe lab. Here's what you're going to need for the lab. Grab yourself a calculator, make it easy on yourself, use a calculator today. Writing utensil, use a pencil. When you're doing data collection, you will make a mistake. You'll write something down wrong. I'm going to use red pen because it shows up better on the camera. For you, use a pencil. Trust us, it will go better. You're going to make a mistake. You're going to want to erase. You're going to need your Expanding Universe pre-lab sheet. That's this one right here. The post-lab is on the other side of this. And you're going to need your Expanding Universe lab sheet. You're not going to be allowed to collect your other equipment until you have gotten a stamp on this pre-lab sheet. So you're going to have to fill this whole thing out, get a stamp on it. It does ask you to define your roles, what scientist is going to do what. Normally our lab groups are 4 people, 1, 2, 3, 4. In this one, you're just going to do this in partners. So you only need 2. You can cross scientist 3 and scientist 4 out. So once you're finished filling this whole thing out, you call your teacher over, you get your stamp, then you can come get your other materials, which are our string of galaxies. These are galaxies. Metal washers with rubber bands connected. We're calling those galaxies. And then you're going to need a meter stick here. We are going to use the metric side of this always. We hardly ever use inches in our class. Actually, there's only 2 times in the entire year that we use inches or feet. We always use metric other than that. So use the metric side, and keep in mind, you are going to be as precise as possible. If you look at this, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15. You're not going to round to a whole number here. There are 10 dashes in between each one of these numbers. So you're going to go to 1/10. So if you're looking at this spot right here, that's going to be 11.4. You are going to be as precise as possible in all your measurements throughout this entire class, starting today, all right? Okay, this lab is really pretty darn easy. You've already got your pre-lab questions filled out. I'll let you read those and answer those on your own. So let's start with our instructions. Independent and dependent variable, you're going to figure those out. Your constants, you're going to figure those out on your own with your group and your teacher. Let's start with our procedure, though. That's what this video is really about, the procedure, what we do. So first off, we got our galaxy names. This one is our home galaxy, Milky Way galaxy. That's our starting galaxy. That's going to go right on top. The whole thing's going to go on top of our ruler. The other galaxies, you can use actual galaxy names, or you can just name them whatever you want. So you got Milky Way to start, and then you got whatever you got after that. I'm just going to do our first 2 galaxies. I'm not going to measure the rest. You're going to do those on your own. I'm just going to show you how with the first one. So procedure step 1 says, lay your rubber universe out in a line, fix it in position, and measure the distance from the Milky Way galaxy, the first washer, right here, to each other galaxy. Use the scale 1 centimeter equals 1 kilometer. Note, in reality, it would be closer to 1 centimeter equals 10 to the 20th kilometers. That's a 10 with 20 zeros behind it. Pretty big number. We're just going to go with 1 to 1. Record this information in table 1 below. So that's what you got to do. You got to put this on there. Just set it right on top of your ruler. And your starting galaxy, home galaxy, Milky Way right here, starts at 0. So I'm going to write down my galaxy name, Milky Way. Like I said, I'm only going to do the first galaxy after that. So this one right here, I'm going to name that after my wife, Megan. So you got Milky Way galaxy right here, Megan galaxy right there. Milky Way galaxy starts at 0, and notice it's the very left edge of the washer that starts at 0. So every washer after this for the rest of the entire lab, you're going to measure at the very left edge of the washer right there, or right there, or right there, or right there, or right there. Just remember, each time you stretch, it's whatever edge of the washer was at 0. If I flip this ruler over, then it would be the right edge, but it's the same edge that's at the 0 of the original washer, right? The edge of the washer that's closest to the beginning point right here, okay? So right now, obviously, Milky Way is right here, so it's at 0 starting distance, right? It's at 0. And no matter how far I stretch this, I'm always going to hold my Milky Way galaxy in place. That's what your partner's going to do. So this is the two different roles that you'll play. One is the stretcher and one is the holder. But the Milky Way, notice it doesn't move. It stays in the exact same place, right? So no matter how far I end up stretching this thing, Milky Way galaxy is always going to be right at 0. So that final distance is going to end up being 0, 2. So the change in distance will be 0 and the velocity will be 0. So for Milky Way, that's going to be zeros all the way across for every single person. You could add that on right now. Now, I don't have a partner with me, so I am going to use a clip to hold this thing on here. Got a really heavy duty clip here. Hold this on nice and tight. And clip it on. Again, I kept the washer right at 0 there. And the rest of the washers are going to lay on top of the ruler there. Now, before stretching, I have to measure each of these. So I'm just going to measure Megan Galaxy right here. So I'm going to measure right to the edge and I'm going to be as precise as possible. Remember, so the edge is right about there. I can move this kind of out of the way. And I see that that is right about at 5.2. 5.2. That's its starting distance from the Milky Way galaxy, 5.2. You will then go and measure each one of these. So you got one more, another one here, another one here, another one here. You will have already named them. You can name them Galaxy 1, 2, 3, 4, and 5 if you want. That's fine. And you would write all those measurements down here. I'm not going to do that, but you need to. So then after I've written down all those measurements there for starting distance, then my partner is going to stretch for me. Now it says in here, let's read instruction number 2. Now stretch your rubber universe to about twice its original size and fix it into a new position. Record this new distance in the final distance column and calculate the change in distance. All right. So I want to go to about double. Now my final washer here is right around 30. You can see it's got 30 right in the middle here. So I'm going to stretch it to around 60. Doesn't have to be exactly that, just around there. And I'm going to hold it nice and tight. You don't want it to wiggle around or your measurements will get messed up. So now I need to look back here at Megan Galaxy and measure to the left edge of Megan Galaxy. So it looks like that's going to about right here. And that looks to be about 8.4. Again, I'm going to be as precise as possible. 8.4, right? Okay, so I'm going to go ahead and unstretch these. You would need to measure all of them while they're being held nice and tight, stretched out. Okay, so you're going to measure all of them. I'm just doing the first one. 8.4. Now is where I need my calculator. So my change in distance is going to be my final distance minus my starting distance. So 8.4 minus 5.2 equals 3.2. So my change in distance is 3.2. Now, last step, step number 3, says, next, calculate the speed at which those galaxies were moving. Let us imagine that it took you 2 seconds to make that last stretch. Remember, speed can be calculated by dividing distance by time. So our time is 2 seconds. That means we're going to use 2 seconds for every calculation on here. My distance in this case was 3.2 kilometers. So we're saying Megan Galaxy moved 3.2 kilometers. And it did that in 2 seconds. So 3.2 divided by 2 equals 1.6. So the velocity of this galaxy was 1.6 kilometers per second. Now I don't have to write down my units here, kilometers, 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 kilometers per second, because they're already listed in the top of each of these columns. That's the rule. If I don't have them listed in the top of the columns, I have to put units by every single number. That's the rule in science. But since they're already listed here for us, I don't actually have to do that, which is kind of nice. The next thing we're going to do down here is graph our data. Plot the starting distance from the Milky Way on your x-axis. Make sure and read the instructions because you got to do your graph this way. And the velocity of the galaxy on your y-axis. So that means you might want to write this down. This is going to be x starting distance from the Milky Way galaxy on X, starting distance on X, and velocity on Y. Starting distance on X, velocity on Y. Flip our paper over and we can see our graph, right? Check these boxes as you go. Make sure you do all these things to get full points. Give your graph a title. Label your axes and include units. You already know what those labels are. You just checked them over here. The label of the x-axis is starting distance from Milky Way. The label of y is velocity of the galaxy. So you can say starting distance and velocity. Shorten up those labels if you want. That's fine. Scale your graph appropriately. Now you're going to have to see what happens with your data, right? You're going to have bigger and bigger and bigger starting distances. My biggest starting distance is somewhere around kind of close to 30, remember? So that means my x-axis is going to need to go up to somewhere close to 30. You need to decide what that maximum number is and then divide accordingly. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces going across, 10 spaces going up. So find your biggest number that you want to go up to, divide by 10, and that's what each of your increments is going to be. For me, I would make this go up to 40 because I know my largest number is 30. So if I go up a little higher than that, I know I can fit all my data in there. And 40 divided by 10 is 4. And I can count by 4s pretty easily. 4, 8, 12, 16, 20, 24, and so forth. So pick a number that's easy to count by when you do that. You don't want to be counting by like 3.25s or some craziness like that, right? So make your largest number here go up a little bit higher than whatever your largest data point was. So, and make it go up to a number that you can count, that'll give you an increment you can count by really easily. So remember, this is going to be your starting distance from the galaxy. This is going to be your velocity, right? After you're done graphing, now, if you need help with this, please ask your teacher. The graphing can be the trickiest part when you're not really experienced with graphing, right? And then once you get all your dots on there, you're going to use a ruler to draw your line of best fit through all your dots, right? That means the straight line that comes closest to every single one of the dots. Your dots might all line up in a perfectly straight line. They might be a little bit scattered depending on how your data came up, but you're going to draw the best fit line you can do through that. After that, you'll answer these questions. Remember, claim evidence reasoning questions are pretty simple and straightforward. After that, here it says, question 2 in the analysis, no model is ever perfect. What are some limitations of the rubber band model for thinking about the universe? That means, how do rubber bands and washers actually not do a good job representing galaxies? I think you can probably come up with something pretty good there.